Now, for the specific heat, we have the specific heat. Okay. The specific heat of a substance is defined as the quantity of heat required to change the temperature of unit mass through a degree, where your specific heat is, the symbol is C, that is equal to the heat over the mass multiplied by the change in temperature, where C is the specific heat, Q is the heat, M is the mass, and delta T is the change in temperature. Now, for the particular mass, your heat now would be equal to M times the integral of C dt. Okay, therefore, with the limits from 1 to 2, when we simplify that, we can say that your heat is equal to mc T2 minus T1. Okay, where C is a specific heat, M is the mass, and T2 is the temperature, absolute temperature at state 2, and T1 is the absolute temperature at state 1. Now, we have the constant volume specific heat. Okay, the symbol is CV. We have QV is equal to delta U, where delta U is the change in internal energy, where the heat at constant volume is equal to mCV T2 minus T1. Then we have the constant pressure, specific heat. Okay, the symbol is CP. Okay, we have heat at constant pressure is equal to delta H, where the delta H is equal to mCP T2 minus T1. Now, we have the ratio of specific heat. The ratio for the specific heat is K is equal to Cp over Cv. But always remember that the ratio of specific heat is always less than 1. Okay, then we have the internal energy of an ideal gas, which is delta U is equal to mCv T2 minus T1. This one is under the Joule's law, states that the change of internal energy of an ideal gas is a function of only the temperature change. Therefore, delta U is given by this formula. Now, whether the volume remains constant or not, delta U is equal to mCv T2 minus T1. Next, we have the enthalpy. Enthalpy of an ideal gas. Okay, the change of enthalpy of an ideal gas is given by the formula delta H is equal to mCp T2 minus T1. Okay, whether the pressure remain constant or not. Now, we have the relations between Cp and Cv. That is Cp is equal to Cv plus R, where R is the specific gas constant. Cv is the constant volume specific heat, constant pressure specific heat for Cp. Okay. Or your CB is equal to R over K minus 1. And CP is also equal to KR over K minus 1.